All right, hey guys, we are going to talk a little bit more about graphing quadratics and kind of put everything together that we did the past 2 days in class. So you should have a packet of problems from the teacher. Make sure you have that out ready to go and your calculator as well. All right, so the first problem I would like you to write down on one of the blank graphs is y equals x squared plus 10x plus 24. So we are going to kind of write down everything we know and then we'll start graphing it. The reason we don't want to graph right away is because I'm not quite sure what I'm going to count by. I know I have to get up to 24 and maybe the points might be higher than that. So I'm going to wait to kind of do my graph. So let's think about what we know. We know the y-intercept is 0, 24. So you can list that down there. Let's find the vertex and the line of symmetry. So to find the line of symmetry, you guys know we've done this the last couple of days. We use negative b over 2a. Remember, this is the a, this is the b, this is the c. So I'm going to do negative 10 over 2 times 1, which gives me negative 5 for my line of symmetry. I will be counting by ones that way, so I'm already going to go to negative 5, 1, 2, 3, 4, 5, and I'm going to put my line of symmetry in there, or my axis of symmetry, dashed. Okay, let's find the coordinates of the vertex. So it's negative 5 comma something. So remember, to find that, you need to plug in negative 5. So I'm going to do negative 5 squared plus 10 times negative 5 plus 24. So you guys can grab your calculator and work that out. I know that's 25 plus negative 50 plus 24, which gives me a negative 1. So my vertex is negative 5, negative 1. Okay, so I'll just kind of do that. Negative 5, negative 1. This is not a great problem. I apologize for the counting. We're just going to count by ones. Okay, my y-intercept is 24. I'm just going to put that way up here and just know that that's 24. And then same over here, that's 24. I would have to go 1, 2, 3, 4, 5 away. 1, 2, 3, 4, 5 away. That's why I put that right there. Okay, I'm also going to label that right away, that's 0, 24. Again, not a great problem. If our graphs were bigger, this would be easier. So I have 3 points so far. Next thing I want to do is try to find my x-intercepts. Remember, I said you always need 5 points. So to find our x-intercepts, we talked about yesterday that all x-intercepts have a y-coordinate of 0. So we're going to put 0 in for y, and to be able to solve this, we're going to try to factor it. Okay, sometimes they won't factor nicely. That means there's not nice y-intercept or x-intercepts. But if I can factor it, it'll work out nice. So I know it's going to be x times x. And then for 24, what times what is 24? But when you add, you get 10. So let's try to think of some numbers. So that looks like 6 and 4. So it's going to be plus 6 and plus 4. All right, now here's where some of you were getting confused yesterday. So for my x-intercepts, what could you plug in here that would make this equal 0? Well, if x was negative 6, that would be a 0. So one x-intercept is negative 6. And then in the second parentheses, what could you put in there so that that equals 0? Well, if that was a negative 4, plus 4 would give me 0. Those are my two x-intercepts. So negative 6 comma 0 and negative 4 comma 0. So I'm going to go to negative 6 comma 0 and negative 4 comma 0. Put some points. I'll connect them up there. Again, I just had to estimate where 24 was. Make a U-shaped curve. Okay, and then the last thing that we talked about is we should always label our special points. So we did label our y-intercept. Our x-intercepts, negative 4, 0 and negative 6, 0. And our vertex is negative 5, negative 1. Okay, our line of symmetry we know is x equals negative 5. And then if we talked about the domain and the range, okay, domain is all real numbers, because that's what you can put in for the x value. And then the range, think the lowest it goes on the graph is negative 1. It's everything above there. So I can say negative 1 is less than or equal to y is less than or equal to infinity. Or I could say just it's all numbers bigger than or equal to negative 1. Those are both ways that you can fill that in. So that was kind of everything that we did with parabolas yesterday, kind of put together. All right, so yesterday we only did ones that had coefficients of 1, like the leading coefficient was a 1. Now I have a 2 there. So let's see if we can solve this one, again, kind of the same way. So let's start with the y-intercept. I think this one will fit on the graph. So go down negative 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, that's like right around here. So I just have to extend it a little bit, which should be fine. There is my y-intercept. Let's try to find the vertex now in the line of symmetry. So I'm going to do negative b over 2a. Remember, here's my a, here's my b, here's my c. So negative b would be negative 5 over 2a would be 2 times 2. So if I do negative 5 divided by 4, I end up with negative 1.25. So my line of symmetry, we're going to have to kind of estimate, is negative 1.25. Now, again, this is not great for graphing, but you kind of get the point. So there it is, negative 1.25. Oh, that's not negative 1.25. I need to erase that. That was only negative 0.5. So negative 1.25 would be somewhere here. All right, now let's go ahead. I'll list this in the box too. I have 0, negative 12 for my y-intercept. My vertex is negative 1.25 comma something. So now we need to come up with that. So I'm going to plug in negative 1.25. I'm going to use a different color just so you guys can see. So I'm going to do 2 times negative 1.25 squared plus 5 times negative 1.25 and then minus 12. All right, that might take you a couple minutes to work out, so pause the video and try that. I'm doing it as well. All right, when I worked that out, I got negative 15.125. Okay, so my vertex is negative 1.25, negative 15.125. So that's going to be down here. Again, had to estimate. Sorry, not the best graph. Okay, then I can do my point a couple away here. And then the last thing I'm going to try to do is find the x-intercept. So I'm going to try to factor this. Now, you're able to do this in a couple different ways, just as an FYI. You can try to factor it using kind of the tricks that I showed you, or you can factor by grouping, which we did last chapter. So I'm going to try it this way first. I'm going to say, hey, 2x times x, I know that's x squared. Those are my only options. Now I need to figure out what times what, how can I split negative 12? Well, there's a couple options. I could do a 4 and a 3, a 6 and a 2, but I need to make a 5 out of it. So this one is probably not the easiest one to factor that way. So maybe I will try doing our factoring by grouping. Okay, so if I draw this little x out, I know when I add, I want it to be 5x. When I multiply, I want negative 24x squared. All right, so what times what is 24? When I add, I get 5. I think it's a 8x and a negative 3x. Okay, so I'm going to split that up into 8x and negative 3x. And I still have 2x squared plus and minus 12. So this one's going to take me a little bit longer. Now let's factor by grouping. So you guys, again, should know how to do this. I can get a 2x out of there. That leave me with x plus 4. Back here, I can get a negative 3 out of there. That leaves me with x plus 4. So I end up with 2x minus 3 and x plus 4. Okay. And then remember, if it's a y-intercept, it equals, or x-intercept, that equals 0. So now this is where it gets a little harder, but I just want to show you one like this. What could I put in here? In this one, I'll highlight it, so that this parentheses would equal 0. Well, that's pretty easy. Negative 4 plus 4. So one x-intercept is negative 4 comma 0. All right, so negative 1, 2, 3, 4. All right, the other one is a little harder, this one right here. What could I put in there so that that equals 0? I'm just going to draw it right here. So 2x minus 3, what could I put in there so it equals 0? Well, you can just set up an equation. If I add 3 on both sides, I get 2x equals 3, and x equals 3 over 2, which is 1.5. So my other x-intercept is 1.5 comma 0, which would be about right here. And if you kind of look at that, I'll try to highlight this so you can see. I'll use my pointer. So if you look at that, it looks to be about the same away from the line of symmetry. So last thing I'm going to do is connect this. Okay, so go ahead and connect yours. Go, just kind of a thin parabola. And there we go. All right, let's try another one on one of your blank graphs. So if you can write this equation down. First thing I notice is my y-intercept is 0, -2. So let's put that on the graph, and here we go. Next thing I'm going to do is try to find my axis of symmetry, so -b over 2a. So again, here's my a, b, and c. So -6 is +6 over 2 times 3 is 6 over 6, which is the same as 1. So my axis of symmetry is nice this time. It's just 1. So you guys can draw that in. So my vertex is going to be 1 comma something. 1's kind of nice to plug in. I'll just plug it in over here. So I've got 3 times 1 squared minus 6 times 1 minus 2. This shouldn't be too bad. So I get 3 minus 6 minus 2, which ends up being -5. So my vertex is 1 comma -5. Okay, I can add the other point across from it. Now I just have 2 more points that I need to try to find. So if I can, I'd like to find the x-intercepts. If there are no nice x-intercepts, then I will just try to pick a different point. So let's try to factor this. So I'm going to try to factor it by grouping. So I'm going to think, okay, when I add, I want -6x. And when I multiply, I want -6x squared. So I need to think what times what is -6, but when I add, I get -6. Well, if I use a 2 and a 3, that won't make a 6. A 5 and a 1, or a 6 and a 1 won't make a 6. So this one, I cannot factor, so that means the x-intercepts are not nice. There still are x-intercepts. You guys can clearly tell there's still going to be x-intercepts when I do this, but they're not going to be nice. So I'm just going to pick another random point. So remember what you can do if there's not nice x-intercepts. Eventually we'll be able to find the exact x-intercepts, just not yet. You can just pick a point to plug in. So maybe I'll just plug in, let's do -1. Okay, so that will be a nice easy one to plug in. So I'll do 3 times -1 squared minus 6 times -1 minus 2. So the other point I'm going to get is -1 comma something. So this is 1. So I get 3 plus 6 minus 2. So 9 minus 2 is 7. So -1 comma 7. 1, 2, 3, 4, 5, 6, 7 is right here. Then I'll do the same thing right across from it, which is right there. And I can connect my parabola. And there we go. Then the last thing, we should just label some points. I've got 1 comma -5. My y-intercept is 0 comma -2. I do not have nice x-intercepts. So there we go. We just graphed a parabola. Okay, the last one I just want to talk about is one that goes upside down. So on this one, I want you to try this one on your own. When you're done, push play, and I'll put the answer. Now, I'm going to tell you, I don't need you to find the x-intercept, so you can just pick a different point. So do not factor this one. Just try to go ahead and pick a different point that will work on this. And then when you are done, you can push play, and you can check your answers. All right, so if you did this one, hopefully you put your y-intercept on -3. You can see that there. I put that there. I got my axis of symmetry to be -1, so I did that dashed line. Then I plugged it in. I got -1 comma -1. So then that was my vertex. I knew this parabola was going down because it was negative, so I knew it had to go this way. I put my opposite point across from it, and then I just picked a random point to plug in. I picked 1 comma whatever. So I plugged in a 1. I got -9, and then I did the point right across from it from the line of symmetry, and there is my parabola. All right, so I know that was a lot of examples, kind of putting a lot of things together. So your homework is to try the 4 other quadratic problems that are in the packet that I have for you. So if you can try those, they will be due on Friday for us because we are STAR testing tomorrow. So please make sure you try those 4 other quadratic problems that are attached. And we'll go over more on Friday.